everyone, I am Rajini. I am currently studying in BTech first year CSC branch at SRIT. Today I am going to discuss with you about the topic of principles and applications of NMR and IR spectroscopy. The outline of this video presentation is definitions of NMR and IR spectroscopy, introduction of NMR and IR spectroscopy, principles of NMR and IR spectroscopy, instrumentation, types of NMR and IR spectroscopy, important vibrational regions, applications, disadvantages, advantages and conclusion for the NMR and IR spectroscopy. First of all, introduction to NMR and IR spectroscopy. What is meant by NMR and IR spectroscopy? The abbreviation of NMR spectroscopy is nuclear magnetic resonance. It is used to determine complete structure of organic molecules. IR means infrared spectroscopy. It detects the bond vibrations to identify functional groups. NMR spectroscopy. NMR spectroscopy, certain nuclei 1H, 13C behave like tiny magnets. In a strong external magnetic field, nuclei occupy energy levels. RF radiation causes transition between energy levels in resonance. Absorbed energy is converted into a spectrum. And then principle of IR spectroscopy. IR spectroscopy molecules absorb infrared radiation causing vibrational transitions. Each chemical bond absorbs a distinct frequency and produces IR absorption peaks. It has only bonds that show a change in dipole moment can absorb IR radiation. The IR spectrum is used to identify functional groups and confirm the molecular structure. The amount of absorption follows Beer-Lambert's law, which means absorbance concentration. Instrumentation behind the NMR and IR spectroscopy. NMR spectroscopy instrumentation is magnet, radio frequency, that means RF generator, sample holder or NMR probe, detector or receiver coil, computer for spectrum output. And the instrumentation behind the IR spectroscopy is IR radiation source, monochromator, sample cell, detector, computer or recorder. Types of NMR and IR spectroscopies. NMR spectroscopies involves 1H NMR, that means proton NMR, 13C NMR, which means carbon 13 NMR, solid state NMR, two-dimensional NMR, which means COSY, HSQC and NOESY. IR spectroscopy involves near IR 14,000 to 4,000 cm -1, mid IR 4,000 to 400 cm -1. It is most analytical use, and the far IR between 400 to 10 cm -1. Interpretation parameters of NMR spectroscopy. Chemical shaft, spin splitting, integration curves, that is area under peak, and coupling constants. Important vibrational regions of IR spectroscopy. Functional group and frequency range. OH stretch frequency range is 3200 to 3600 cm -1. C double bond O stretch is frequency range is 1650 to 1750 cm -1. C single bond H stretch frequency range is 2800 to 3000 cm -1. NH stretch frequency range is 3300 to 3500 cm -1. Applications of NMR spectroscopy is full structural elucidation of organic compounds, purity checking and impurity identification, stereochemistry and conformational analysis, biomolecular studies like proteins, DNA, NMR spectroscopy is applied. MRI technique in medicine. Applications of IR spectroscopy. IR spectroscopy applied in functional group identification, reaction monitoring, quality control in pharmaceuticals, material analysis, which means polymers, fibers, rubbers, etc. and environmental testings like gases, pollutants, etc. and food and oil adulteration detection. IR spectroscopy is applied in these processes. Advantages of NMR spectroscopy. It provides complete molecular structure including atom arrangements. In destructive technique, sample can be recovered. Quantitative and qualitative analysis is possible by NMR spectroscopy. It determines stereochemistry and conformation of molecules. NMR spectroscopy has high accuracy and sensitivity for identifying organic compounds. It has capable of detecting impurities and mixture composition. It is useful for studying biomolecules and solution state dynamics. Advantages of IR spectroscopy involves quick and simple technique for functional group identification, non-destructive like sample does not undergo chemical change. It requires very small sample quantity. It works for solids, liquids as well as gases also. It gives a molecular fingerprint spectrum for precise identification. It is useful in quality control and reaction monitoring. Instruments are relatively cost effective and easy to operate. Disadvantages of NMR spectroscopy is it has very expensive instruments, which means high cost of superconducting magnets. It requires relatively large amount of sample compared to MSR IR. NMR needs higher sample concentrations. High resolution or 2D or 3D NMR experiments can take a long time to acquire. Analyzing and assigning peaks often needs expert knowledge. Components in a complex mixtures may produce overlapping signals, making analysis very difficult. These are the disadvantages of NMR spectroscopy. And the disadvantages of IR spectroscopy involves it cannot detect atoms or molecules without dipole moment. For example, O2, N2, Cl2 do not show IR spectra. Limited in identifying complex mixtures because overlapping peaks make interpretation difficult. It needs pure samples for accurate analysis. Impurities disturb spectra. Cannot determine exact molecular structure, which means only functional groups can be confirmed by IR spectroscopy. Water strongly absorbs IR radiation, so aqueous samples cannot be analyzed easily by using IR spectroscopy. Sample preparation may be difficult, especially for solids and gases. Weak sensitivity for low concentration samples, resulting in poor detectability. And the conclusion for this video presentation of NMR and IR spectroscopy is IR and NMR are essential techniques for identifying molecular structure. IR detects functional groups by measuring bond vibrations. NMR gives detailed information about atom arrangement. Both methods provide quick and accurate analysis. They are non-destructive techniques. Together they give a complete understanding of a compound. And this is the video presentation of NMR and IR spectroscopy, and thank you for listening this video presentation.